All right, today, folks, we are live during Geometry Period 2. As a reminder, if you want to ask a question, you can ask. It'll just be on the recording. If not, there'll always be a Q&A at the very end. Today, we're going to talk about 10.2, finding arc measure in circles. So let's start off with a little bit of vocab here. As we kind of follow along with what your book has, we've got central angle. So that's an angle that's formed by two radii. Radii, and has a vertex at the center of the circle. The measure of the minor arc is the measure of the central angle. So the central angle will be the minor arc. The measure of the major arc is always going to be 360 minus the measure of the central angle, or the measure essentially of the minor arc. So if you take a look at these two arcs, okay, if you notice up here it says minor arc. Okay, I'll underline this right now, minor arc AB. Notice how it's just denoted as AB. That notes that it's a minor arc. A major arc usually is ADB, or 3 letters. How to distinguish between the two? A minor arc is going to be less than 180 degrees, or less than halfway around the circle. The major arc is going to be greater than 180. If it is exactly 180, we call that a semicircle, which is just meaning half of the circle. And then it'll also probably be 3 letters to note which way you're going around or what you're looking for. Here's a quick example that I wanted to show you and kind of do with you on this. If you take a look at this picture and just kind of what it's looking at, RS, okay, it's asking you for a minor arc that's labeled, which is 110. That should be RP. RTS. No, RTS. Sorry, that is right. Would be the entire way around. So that would be considered your major arc. So in order to find that, we take 360 minus 110 to get 270. And then if you look at how it says RST, I'll do this in red here. RST. You have to go across S in order to get the T. That's going to be our half, which is our semicircle. So 180 degrees, because half of 360 is 180. So when you're doing this, make sure to look. If there's 3 letters you want to cross over when you're going around your circle, you want to cross over that middle letter that they have there for you. Questions at all so far? Okay. I feel like you guys have maybe seen some of these before, or a little bit of it. First postulate that we have here is the arc addition postulate. It's the measure of an arc formed by 2 adjacent arcs. Yeah. Let me back up here. The question was, how did I get 270? So the one that's looking for is RTS, which is here. I took the 360 degrees total and then subtracted the part that it didn't want, which is the 110. Is it 250? Oh my gosh, you're right. Thank you for correcting me. It is. I apologize, guys. I make mistakes too. It is 250. Okay. All right, let's backtrack to this postulate here. Do over. Arc addition postulate: the measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. So all it's telling you is that if you wanted, for instance, if you wanted ABC, okay, let me draw this in red. A to B to C, here to here. I could take the measure of A to B plus the measure of B to C, and then that would end up being the same as ABC. It's literally just you have two arcs, you can put them together and add. You'll see that in problems like the first example here. The second example says find the measure of each arc. So letter A here, GE, we have arc addition postulate basically. G all the way over to E. Notice how it has 2. So it is the minor arc, meaning it's going to be a small arc and not go more than half the circle. So I've got 40 plus 80, which is going to give me 120 degrees.
Mr. Stewart,
Yeah.
could it it can't be it can't be more than 180? You said because it's not because it's the minor arc.
Correct.
So if it what if the other number was we'll just say 100? It can't be that, or that's the maximum it can be.
It could. Well, it couldn't be. The maximum that it could honestly be is 180. It has to usually be less. It's mainly because see how it's 2 letters.
Yeah.
2 letters means that it's minor, which means that it's going to be less than 180. If that was 3 letters, if it would have said G F E, then it would have went the other way. Then it would have been a major arc. If that kind of helps. For example, if you look at this next one, I'm going to do this next one in red. Okay. The next one is G E F. So we start at G, we cross over E, and we go the whole entire way to F. So they use 3, so we know that our answer is going to be more than 180 degrees, or maybe 180 degrees at most. So 40 plus 80 plus 110. That gives us 120 to 30. And then the last one there is GF. So start at G, go to F. So here's the deal. If we know that in red, that's 230, and GF is the rest of the circle, then we'll subtract 360 minus 230. Okay, and this time I promise I'll get my math correct. It's 130 degrees. Okay. Questions at all so far? Not too terrible, right? The stuff, it could be a lot worse than some of the things that we've kind of dealt with in here. Take a look at example number 3. A recent survey asked teenagers whether they'd rather meet a famous musician, famous athlete, a famous actor, a famous inventor, or somebody else that's famous. The circle graph shows the results. Find the indicated measure. So it says the measure of AC. Again, it's going to be our minor arc. A all the way to C. Now, here's the deal. It says 8% and 30%. It doesn't actually tell us degrees. So we're going to have to convert that into degrees using percentages. So a way to do this, okay, is first add up our total. So I'm going to do my work for letter A here. 8% plus 30 is going to give us 38%. And then what we can do from here is we can do 0.38 times 360, because that'll be 0.38 or 38% of our entire circle, and our entire circle is 360 degrees. So go ahead and I'm going to get my calculator out for this. 0.38 times 360. And I get 136.8 degrees. Okay. So it's a tiniest bit different than what we've seen. Usually they give us the degree. In this case, they give us a percent, so we have to use that percent out of the whole entire circle. So take a look at letter B. I'm going to do letter B in red. It wants us to find ACD. So ACD. So that first part we had 8% plus 30%, so 38%. So now we're going to have 38 plus 23, which gives us 61. So I'm going to write that out for you just so you have it in your notes. It was 8 plus 30 plus 23. So we have 61%. So we'll take 0.61 times 360 and get our answer of 219.6 degrees for those that want to meet a famous inventor, a famous musician, or a famous athlete. I don't know which one I'd pick personally. Musician, yeah. I was kind of leaning that way. Famous musician would be pretty cool. All right, so let's go ahead and go into congruent circles theorems. This is one of the last things that we have, really. Congruent circles theorem is just stating that two circles are congruent circles if and only if they have the same radii, which means the radius has to be the same length. So we could have two circles that look identical, but if the radius is not the same length, then those are not congruent circles. We also have the congruent central angle theorem. So in the same circle, or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. And so if you take a look here, you've got the central angle of BCA congruent with DAE. And by doing that, it means that those two parts of that arc are also going to be congruent as well. Does anyone remember the name for those two types of angles that are in there? Vertical angles. Good. Yeah, vertical angles. And vertical angles are congruent. So we've got two more examples here. Or I'm sorry, one last example here for you. Tell whether the indicated arcs are congruent. Explain why or why not. So on letter A, RS and TU, we want to see if those arcs are the same. Okay, we're looking at this arc here and this arc here. Would these two arcs be congruent? No. Yeah, these two arcs would not be congruent. Okay, if you take a look at this, QR is going to be less than QT. So just kind of make a note here. Radius QR is going to be less than radius of QT. In order for them to be congruent, they have to be the same. Take a look at letter B. Letter B, it's pretty obvious. Both the central angles, 95 degrees. Okay, TV and XZ are both the same length, meaning that the radius is both the same. So yes, these would both be congruent arcs and making them really congruent circles. So yes, central angle, the same. And the radius is also the same or congruent.